Okay, today we are working on a multiple choice question that comes from a released AP exam for Calculus AB. The topic in this question is differential equations solved by separation of variables. The question says, if dy over dt equals ky, and k is a non-zero constant, then y could be which of the following? The question says, dy over dt equals our constant k times y. Now in separation of variables, our goal is to get all of one type of variable, so in this case all of the y's. We want to move to the left side of the equal sign, and we want to get all of the other type of variable, in this case a t, to the opposite side of the equal sign. So we need to move this dt over to this side of the equal sign. We're going to do that through multiplication. Multiply the left side by dt, multiply the right side by dt, and we're going to end up with dy equals our constant k times y dt. Well, we have our t's on the right side, we just need to get our y's on the left. So we're going to divide both sides by y. If we divide the right side by y, those will cancel out. Divide the left side by y, that's going to leave us with dy over y equals our constant k dt. Once we have all of our variables separated, all the y's in this case on the left, all the t's on the right, our next step is to integrate. So we're going to integrate the left and integrate the right. Well, the integral of dy over y is the natural log of y. Well, it doesn't have any upper and lower bounds, so we have to add plus c equals, now the integral of the right side, well, we're integrating just a constant. So the integral of just a constant is the constant, and you add in the variable with which you are integrating with respect to. Same with this side. It has no upper and lower bounds, so we have to add a plus c. Well, we have multiple c's now. We kind of have to keep these organized because we can't guarantee that they are the same c. So the c on the left, we're going to say this is c sub 1. The c on the right, we're going to say that's c sub 2. They're both constants, we just can't guarantee they're the same constant. Now the question, if we go back to it, it says, then y could be which of the following? It says y. We need to solve for y. That means get this piece all by itself. Well, first step, we need to move our c sub 1 to the right side. We will subtract c sub 1 from both sides. That'll leave us with the natural log of y on the left equals constant k times t plus, well, we have a constant minus another constant. Those constants combine, creating another constant. Who knows if it's positive or negative? We can always just say plus a negative if we have to, constant. Okay, so natural log of y equals kt plus a constant. Now we need to get y all by itself. We have to get rid of that natural log. Going back to pre-calculus, if we want to cancel out a natural log, we are going to make it an exponent with the base of e. So e raised to the natural log of y. Well, what we do to one side, you have to do to the other. So make the other side an exponent with the base e. The reason we did that, the natural log and the e cancel out, leaving us with just y equals, and we can't really simplify that as of yet, so we're just going to leave it as e to the kt plus our constant. Now take a look at that exponent. There is an addition sign in that exponent. Think where else you've seen addition in exponents. Going back to algebra 2, if we have x to the third power times x to the fourth power, well, when you multiply two numbers with like bases, you add their exponents. So that is x to the seventh. We just said we add their exponents. That's what we're doing with our problem. We have an addition sign in the exponent. So that means if we want to kind of decompose this exponent, we can rewrite it as the multiplication of two numbers with like bases. So we can take this, rewrite it as e to the kt times e to the c. Because if you multiply those back together, multiplying two numbers with like bases means you add their exponents, and we would be back to the same thing. So, e to the kt, that has a variable in it. We can't really change that as of right now. On the other hand, e to the c, e is just a number, 2.71, raised to a constant, another number. If you pick any c value and plug that in, you will end up with another constant. So we can change this to our fourth and final constant, c sub 4. So that means we're going to have our e to the kt times our c sub 4, our fourth constant. Now kind of rearranging this to look like something we've worked with in the past. Y equals, move the constant in front of the e. We're going to have c e to the kt. We have solved for y now. We have y all by itself in its simplest form for the most part. Let's go back up to our answer choices. Which one of these answer choices could be a possible answer? Keeping in mind that c could be any constant. Well, first of all, we want to look for an answer choice that has e raised to the kt power. That means that this doesn't, d does not, c does, b also does. A has e to the kt, but it also has a y in there, so that's not exactly the same, so that goes away. That is leaving us with b and c. Well, the only answer choice that has a constant in front of our e to the kt is b. So that is our final answer. That could have been any constant and been a possible choice for y, but in this case it turned out to be a 2. If you enjoyed this problem, please like, subscribe, and if you have any recommendations for future topics that you would like to be covered, please just let me know either in the comments or direct message me, and I will do my best to cover that topic, okay? Thank you.